So what are you guys?
We are the Swartwood family!
Hey guys, I thought it'd be good to do this combination problem, and this is a pi problem. So basically, let's say you have 10 red balls, 10 blue balls, and 10 orange balls. Okay, let's add 10 yellow as well. Right, and what you're going to do is you're going to pick 30 of them, and it's supposed to be a question mark, my bad. And the question is, how many ways can you do this? Okay, so it's important to think about this and try it. You could try doing it directly, and there are a lot of cases, right? You can have 10 red, 8 blue, 8 orange, 4 yellow. So many different cases. So that's kind of a pain. The other thing is you have these restrictions. These restrictions are definitely a pain in the butt, right? Sometimes when the restrictions are a pain in the butt, also sometimes when the counting is very tedious, it's good to kind of look at the complement. So the strategy here would be, instead of going directly for what you want, because that might be hard, you look at all the stuff you don't want, because in this case it's much easier. And that's our strategy. So we're going to do the flip. We're going to look at the complement, because I think it's going to be much easier. Okay, so we're going to count the total number of possibilities without this restriction, which is a pain. We're going to subtract off all the bad cases, right? And then what we'll get is exactly what we want. Because it turns out counting this and counting that may be much better than counting this directly, okay? In a lot of cases. In this particular problem, I definitely think it's the way to go. I mean, we could try to compute it directly later and see, but first, let's do this. So, quick review. Do you guys remember the multinomial thing? Because we're going to have to use it here. So, for example, if I had 2 buckets, red and yellow, and the question is, I have 3 balls, and I want to pick 3 balls, and they can either be red or yellow. No restrictions. They could all be red, they could all be yellow, whatever. One way to do it is take your 3, and then place them in these buckets, like this. And that would definitely represent picking 2 red and 1 yellow. So you can see one easy way of doing this is to have your buckets and then place the balls in the buckets. And that's going to be our strategy. Just to remind you how we do this, like count this. The cheapo way would just be this. Okay, I have 2 buckets, and in those 2 buckets I want to place 3 balls, and that's the answer. But I know we're very comfortable with binomial coefficients. If we want to convert this to binomial coefficients, we can kind of think of it this way. We have, for the red and the yellow, in an arrangement like this, or an arrangement like that. You get all the information you need if you just imagine there's a divider here. Right? To the left is the red, to the right is the yellow. And do you also agree that if we had 3, the number of dividers we would need is 1, 2. So it's always 1 less than the number of buckets. So a way to encode this is, imagine you have 1, 2, 3, 4 slots. And what you need to do is you need to decide, of these, let's name this slot 1, 2, 3, and 4. You want to choose where that divider goes. So let's say right here. Totally fine. Then everything else has to look like this, right? So once you choose that divider, you've chosen to set it completely. There's 0 red and 3 yellow, and that is it. So the way to convert from this to binomial coefficients is going to be basically, you take the number of balls you had, which is 3. You add to it the number of dividers, which is always 1 less than the number of buckets. So 2 minus 1. And then you decide where that divider goes. Okay? Like that. So you choose where the dividers go. So in this case, 2 minus 1 is 1. So it's going to be 4, choose 1, right? Okay. We're picking out where the divider goes. So now let's go back to our current problem. If you remember, it's going to be total minus the ones we don't want gives us the ones we do want. So it's the total size of whatever universe we're looking at. We're going to subtract off, and we're going to sum the sizes of the individual cases. And the cases here, we have 4 of them, right? So the bad possibilities we don't want. So A1 might be something like we have more than 10 red. Okay? Actually, that's kind of confusing. Let's rewrite that like this. So more than 10 red. In case 2 is we have more than 10 blue. In case 3 is we have more than 10 orange. In case 4, because these are all bad cases, we have more than 10 yellow. And you can already see we're going to double count, because in some of the cases where you have more than 10 red, you also have more than 10 blue. So if we count that case here and here, we're double counting. So to fix that, we're going to have to add back the cases where you have all the pairs. Okay? And then you're going to subtract off the triple intersections. And then you're going to add back the quadruple. Now I'm going to make this look cleaner, but I just want it to be, sorry, the handwriting's getting a little sloppy. I just want it to be as general as possible for the moment. Okay, let's make this look better. So you have the universe of possibilities. We're going to take out the sum of, we can actually write all these out. It's really not that bad. So let's do that. We're going to subtract the size of A1 plus the size of A2 plus the size of A3 plus the size of A4. Okay? And then we're going to add back the double intersection. This might be a little bit more painful. So what I'm going to do is I'm going to just do a couple examples. The size of A1, A2, right, plus A1, A3, and etc. And then subtract off the triple intersection. So this is actually going to be nicer than it looks. I'm just going to list one triple intersection to make my point. Okay, etc. And then there's only one quadruple intersection, and that's going to be 1, 2, 3, and 4. Okay. Now this looks kind of nasty, but it's going to get way, way better. So let's think about this logically. So to have all 4 conditions, that means you have to have, well, if you have more than 10, the minimal amount would be 11, 11, 11, 11, right? But that alone is 44, and you're only picking out 30. So remember, the big thing was you're picking out 30 balls. So there's no way this can happen. In fact, we're lucky because here, for any triplet, you'd have 11, 11, 11, and that's 33. That's already over the 30 count. So there's no triple intersections we have to worry about. So what this really comes down to is, let's do this. The universe minus A1, A2, A3, A4, right? Plus adding back all the double intersections. Okay. All right, and then this will actually be not that bad. So let's do this. So first, the cheapo notation. We have 4 buckets, right? We have that red, blue, orange, yellow. And we want to place 30 guys in them, right? So that's going to be 40, it's going to be 4 multi-choose 30, okay? We'll write this out, but first let's just do this so it's organized, okay? Now, let's take out the individual ones. So let's just take one as an example. So let's focus on this guy. So for A1 to be met, just A1, what does that mean? So you have to have more than 10 red. So the minimum number would be 11 red in that red bucket, right? But 30 minus 11 is 19. So now you have 19 balls to place wherever you want, right? Including the red. So everything's legal. So you have 19 more balls to distribute. They can go anywhere. So this is equivalent to a problem of just distributing 19 balls into 4 buckets. But you know how to do that. That's going to be the 4 buckets. We're going to place 19. Okay. One thing I want to be careful about, though, especially with this counting junk, is that we took care of case A1. But remember, you have to take care of case A2, and then we have to take care of case A3, and then we have to take care of case A4, right? But each one of them is going to look identical. It's just that instead of having 11 red, we might have, say, 11 blue, or 11 orange, or 11 yellow, you know, etc. So in all these cases, they're identical. There's just 4 of them. So you would get this number exactly, right? 4 times. So it's just going to be this times 4. Okay? All right, now let's add back. So let's take a look at what we're missing here. Let me erase this part here. Okay. So I want to do exactly the same line of thinking. And in fact, let's clean the slate. All right, let's do this. And let's see, maybe like that. Okay. All right. So now what we want to do is say, let's look at the intersection A1 intersect A2. So for this to be met, what we need is in that red bucket, we need at least 11. And in that blue bucket, we need at least 11. And then in the remaining buckets, we can have any number. Okay. So we have 30 balls altogether. We've taken out 22. 8 remain. Those 8 can go anywhere, including the red or the blue, right? So this reduces to the problem of what? It reduces to a problem of having 4 buckets. Actually, let's choose a different color. This reduces to the problem of having 4 buckets and placing out 8 balls in them. Okay? And you agree for any other pair we pick, the argument's going to look identical. But now the question is, how many different pairs can you get? Well, you know this. You have 4 colors, red, blue, orange, yellow. And you want to pick out any 2 of them to be in a pair. So that's actually 4 choose 2. And if you go back and think about the previous case we looked at, it's like you have 4 buckets and you want to pick out one of them. So that's really 4 choose 1, which is 4. So this pattern holds up in general. Okay? So this is actually the answer we want. Now, I know people probably wouldn't be satisfied with that. So let's go ahead and clean it up a little bit, make it prettier. 4 multi-choose 30 is really going to be, think 30 balls. I have 4 buckets. I need 4 minus 1 dividers. Place the 4 minus 1 dividers. Minus. So 4 multi-choose 19. It's going to be 19 balls, 4 buckets, minus 1 to get the number of dividers, 4 minus 1 dividers, times 4. Okay? Plus 4 multi-choose 8. So 8 balls, 4 buckets. Again, the 4 minus 1 represents the number of dividers. So we're going to choose those dividers so we can figure out what's in what bucket. And that's 4 choose 2 at the end. So this is our complete answer. I think really all the hard work is done. You can crunch in a calculator or whatever. I actually did it. I went in this video and I computed it by hand, but I don't think anyone wants to see that, and that's super tedious. So if you, unless I miscounted, you could double check me. I think it's 286. So I hope that helped, and I'll see you guys next time.